Okay, let's talk about how to do number 22. We did a lot like we did number 21, but we're going to look at these because we have these leading coefficients that aren't 1 in this one. We have a leading coefficients not 1, so it's going to be a little bit different. So we're going to look at this on our calculator again. We're going to graph this. 2x to the 4th minus 9x cubed. And negative 12x squared plus 29x. The last one was plus 30. It was plus 30. So this time we're going to graph. And here we see that this intersects at negative 1, it looks like. It intersects at 2, it looks like, and at 5. Negative 1, 2, and 5, but then it intersects over here also. So we got to figure out where that is. So I'm going to look at this and I'm going to go ahead and write down negative 1. Oh, let's look at the table to make sure. At negative 1, at 2, and at 5. So we see those. So that means x equals negative 1, 2, and 5. This means, let's go, that x plus 1 has to be a factor. So we're going to look for that. All of them have x plus 1. This means that x minus 2 has to be a factor. So we're going to look, they all have x minus 2's. This one means x minus 5 has to be a factor. So it looks like only one of them has x minus 5. So I'm guessing it's going to be this one. Now, let's look. We've got the x plus 1. We took care of that. We got the x minus 2. We took care of that. We took the x minus 5. So the last thing we need to check is this 2x plus 3. If 2x plus 3 is a factor, then that means if we set it equal to 0, it has to be true. So we subtract 3 from both sides, and we get 2x equals negative 3. And we divide by 2 on both sides, and we get x equals negative 3 halves. That's negative 1.5. If we look back at our graph, we see that this actually does intersect at negative 1 and at negative 1.5. So B is our answer there. So B is our answer for number 22. That's how you do number 22.